Here's some more factorising from New Lake, pages 7 to 10. I did this one on the last tutorial. We were doing it in two parts. So we take the first bit, 3ac, and factorise, we get e plus 1. We do the second part, 6b, negative 6b, and we get e plus 1. Then when we take the factor of e plus 1 and put that outside the brackets, we get e plus 1, and inside we have 3ac minus 6b. Now I said that that was factorised fully. Is it? It's almost factorised fully. You've still got a 3 inside that bracket which you can take out. And there is the 3 taken out. We normally put the 3 right at the very front and the two brackets together. Now that's factorised fully. Here we're going to factorise this one. Make sure you complete the second part of this. One answer that I got was x minus 10 times x minus 10. That is correct, but just finish it off. That's the same as x minus 10 all squared. Think about these two examples. The first thing that you should do when you get examples like this is to see if there's a common factor in each of them. For example, 3 will divide into each of those terms, but 3 won't divide into each of those terms because 3 won't fit into the 7. So for the first one, we treat it slightly differently. First of all, remove the 3 outside the bracket, so divide every term by 3, and you would get this. Then the second part can be factorised really easy into two pairs of brackets, x minus, 3 ones are 3. So there we're done. That was fairly easy. But the other one requires the ACC method that I use. Assume, calculate, cancel. So we're going to assume that it's 3x times 3x divided by 3, and list the factors of 3 times 6, which is negative 18. So list the factors of negative 18. We know that 2 times negative 9 make negative 7, which is our middle term. So you see your middle term there is negative 7. 2 minus 9 is negative 7. So we know that it's 2 and negative 9 in the brackets. Now the 3 will cancel nicely into both parts of the second bracket. So remove the 3 outside, cancel the 3 which is a factor, and you get the following. And there we've completed the question. Question 97 is a little tricky. So I would like to remove the 0.5 out of that first. So I'm going to divide 0.5 into each of these terms. Now you might say, where did that 48 come from? Well, when I go 0.5 times 48, I get 24. When I go 0.5 times negative 2, I get negative 1n. That's where I get it from. Then you can factorise the rest nicely. N minus, n plus, one's plus and one's minus. Factors of 48 that differ by 2 are, we can see 6 times 8, and negative 8 plus 6 make 48. Sorry, they times the 48, they make negative 2. So there's our final answer, and we're done. And there we have some power in mathematics.